Hey there guys, how's it going? This is Mike here. Today we're going to talk about the product and the quotient rule. We're going to use these guys to learn how do you come up with the derivatives of products of functions as well as quotients of functions. These are two very, very important rules that you need to know for any basic Calculus 1 class. And you need to get these guys down stone cold. So we're going to go through these guys right now. We're going to kick it off with the product rule, which we're going to use to differentiate the product of two functions of x. So if we have the product of two functions, say f of x and g of x, what is the derivative of that product going to be? Well, first we're just going to look at the basic definition of this guy using the limit. D dx of f of x times g of x, using the limit definition of the derivative, is equal to the limit as h goes to 0 of the quantity f of x plus h times g of x plus h minus f of x times g of x all over h. Now, from here, it may seem like we're stuck. It may seem like we don't know what the heck we can do from here to get this down into some kind of relatively nice formula. Well, we're going to pull a little trick here. It's not the most obvious trick, but it is a 100% valid trick. So we are going to use this little trick, and this is going to turn this into something that we can work with. We're going to pull the trick of adding and subtracting the same thing from the numerator of the fraction that we have inside of our limit. And what we're going to add and subtract in the numerator is the quantity f of x times g of x plus h. So we're adding and subtracting that guy right there. We're just adding a big fancy 0 to this. We're not changing the actual quantity that we have. So now, I'm going to look at this entire thing, but in two separate chunks. I'm going to look at it as these first two terms over h plus those two terms over h. Now, looking at everything that's circled in red, we see that both terms in the numerator have a common factor of the g of x plus h. That guy right there, and that guy right there. So I'm going to pull that common factor out of these guys. Now, looking at everything that's circled in blue, I see that both terms in the numerator have a common factor of f of x. So I'm going to pull that common factor out of those two terms there. We're taking the limit of this whole thing. So we're going to have a product of two things plus another product of two separate things. By our properties of limits, we know that the limit of the sum of two things is equal to the sum of their individual limits. And we know that the limit of the product of two things is equal to the product of their individual limits. So what this big limit becomes is this guy right here. A product of two limits plus another product of another two limits. Limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of f of x plus h minus f of x all over h, plus the limit as h goes to 0 of f of x times the limit as h goes to 0 of g of x plus h minus g of x all over h. So let's get into what some of these limits are going to be here. Looking at the first limit here, we're taking the limit of h. So h is the only real variable in the eyes of this limit. X's are just sort of random unknown constants. First thing you always try is just substituting your h value in, and we see that when you do that, you get just g of x. So that's perfectly fine. So that's going to give us g of x. There we go, once it writes. And now this guy over here, the limit as h goes to 0 of just f of x, well, there's no h in there whatsoever. So in the eyes of this limit, this is all just a big constant. And we know that the limit of a constant is just a constant, so that's just going to be f of x. Now, the other two limits here, limit as h goes to 0 of f of x plus h minus f of x all over h. That should look a little familiar. That should look like the limit definition of the derivative for one of my functions here, f of x. And that is exactly what it is. That's just the straightforward statement of the limit definition of the derivative. So this whole guy right here is equal to f prime of x. And by the same reasoning, this limit that I have right here is equal to g prime of x right there. So now we come to the end result and the end statement of the product rule, which is f prime of x times g of x plus f of x times g prime of x. Now, note here that there's a plus sign in the middle of these two terms here. So the order in which you write these things does not matter. Make sure that you're doing the derivative of one times the other plus the derivative of the one that you haven't differentiated yet times the other one that you differentiated in the first term. So f prime times g plus f times g prime. There's another way you can look at this. If you want to call this guy your first function, and if you want to call g of x your second function, then what the product rule basically says then is it's first times the derivative of the second plus the second times the derivative of the first. And note that technically this is backwards. The first term listed here matches with the second term listed at the bottom, and the second term at the top matches with the first term listed at the bottom. But again, the order in which you write these things does not matter. Switch these guys, still come up with the same thing. So that's product rule. In the next video, we are going to look at some samples of how do you use product rule to differentiate the products of functions. But now we're going to move on to the statement of the quotient rule. So as the name of the rule suggests, quotient, you're dealing with the quotient of two functions. Some function f of x divided by some function g of x. And we need to come up with what is the derivative of this guy here. Well, we're going to start off in the same way as we did with product rule. We're going to look at the limit definition of the derivative of this guy. And we see that when we try to use the limit definition of the derivative, it gets incredibly ugly. We have the limit as h goes to 0 of f of x plus h divided by g of x plus h minus f of x all over g of x all over h. Now, this is a complex fraction. we can take this difference of two fractions, that's all being divided by something, and we can turn this all into one fraction. That's going to be some work in and of itself. We then have to get this thing to simplify out, figure what this thing is going to turn out to be. We're not going to go through that in this video. I will say, though, that you are pulling the same kind of trick as we had to pull in the proof of the formula for product rule. You do have to add and subtract something from the numerator of your fraction, and then things nicely combine, cancel out, and so on. And what you get in the end is this guy right here. The derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x all over g of x squared. Now, a big difference that I want to point out in the statement of quotient rule versus the statement of product rule. As we said, in product rule, you're taking the sum of two things. So the order in which you write those things does not matter. We could have done f prime times g plus f times g prime, or we could have done f times g prime plus f prime times g. Either way gets you to the same correct answer. In the statement of quotient rule, we see that there's a minus sign happening here. That minus sign matters. The order in which you write terms in the numerator when you do quotient rule does matter. The order does matter. You have to make sure that you're writing it in the proper way. If you switch things up, you'll be multiplying your answer by a -1, which is not quite what we want to do. So for this one, you have to be very careful. It's f prime times g minus f times g prime. And then it's that guy all over the bottom squared, over g of x squared. Now, this is not the easiest formula to just have branded into your mind. So sometimes we need a little bit of a silly saying or silly thing to help us keep it straight. So something that may help you here. If you look at your top function, f of x, as your high function, and if you look at your g of x there as your low function, then what quotient rule is saying can be thought of as this. Low d high minus high d low all over low squared. Or your bottom function times the derivative of your top function or your high function, that's your d high, minus high, your top function, times d low, or the derivative of your low function, all over the bottom function, your low function, squared. So that's just another way that you can think of the quotient rule. Some folks do find it a lot easier to think of it this way. So this is just the statement of product and quotient rules. In the next video, we are going to look at how do you actually do problems. How do you actually use these guys to come up with the derivatives of products and quotients of functions? So this is the end of the first video. Follow along with me in the next video. Thank you very much, guys, and we'll see you later.